For question 11 I've changed the numbers. I've also gone for a cheap hand-drawn version of the question. So part A, state the full name of the component labelled X. I'm not going to tell you what that is, you ought to know that. The circuit's to monitor light intensity. Just note that the question just said the full name. In other words, the words, not just the letters that you might refer to it by. For my part B, I'm going to find the output voltage when X has got a value of 1.2 kiloohms, different from the value that you've got. So how do we find the output voltage? Well, if we look at the circuit, we should spot straight away it's a potential divider. So we're thinking of potential dividers. If you look at our data sheet, hoping that there's a potential divider equation on there, well, according to the data sheet that's in the book, I can't find a formula for potential divider anywhere there. So you're not going to rely on the data sheet, so you have to know how to do it. And there's various ways of knowing how to do it. Obviously the easiest way is just to learn. I'm actually quite pleased that the potential divider equation isn't given, because really if you just look up that equation you're not understanding any physics. We can work out the output voltage. We can work out the output voltage just by putting together a few simple ideas. We don't need to look up a formula. And there's various ways of doing it. We think about how the voltage is shared between the two resistors, and the share of the voltage is going to be the same ratio as the share of the resistance. So if X is 1.2 kiloohms, we know we've got a total of resistance in the circuit of 4.6 kiloohms, and the voltage is going to be shared out. It's going to be shared out so that this one gets 3.4 divided by 4.6 times the total voltage. So that's one way of doing it, just using the ratio. The other way of doing it is to think about the current in the circuit. To find the current in the circuit, because it's just a simple series circuit, we know that the current in the circuit is the supply voltage divided by the total resistance. And then we know that the voltage across this resistor is the current times this resistance. So we take the supply voltage, we divide it by the total resistance to get the current in the circuit, then we multiply that current by this resistance to get the voltage across this resistance. So whichever way we do it, we get the same answer. We get V out is equal to the supply voltage times 3.4 divided by the total. But I could just write 4.6, I'm going to write 3.4 plus 1.2, just to really emphasise that I know where those numbers have come from. We get an answer of 2.2 volts. Part C, state and explain how the resistance of component X changes when the light intensity falls. So state what happens, you mean does it stay the same, does it get bigger, does it get smaller? Explain, give the reason why it either stays the same or gets bigger or gets smaller. And the reason you give is going to refer to the number of charge carriers. What happens to the number of charge carriers and why? Although when we actually studied this topic we just referred to the light bringing in energy, you do now know about photons. So you know when the light level falls there are fewer photons. So you should better bring that into your explanation, to explain what happens to the number of charge carriers that have got enough energy to be able to move. And then for the final part, if you know how the resistance of X changes, you should be able to work out how the output voltage changes. And that just says state, so you don't need to give a reason. That's just, you're just showing your understanding of how potential dividers work by saying does it go up or does it go down or does it stay the same.